you have a prompt which is given to LLM to generate text for you for solving various kinds of problems. It could be a coding problem, it could be a summarizing problem, it could be, to create a visualization, it could be creative writing, right? So how do you know which is the best LLM for your prompt? You have various LLMs now from different labs. You have Grok, you have Claude 3.7, you have Gemini, you have OpenAI, GPT series, right? So this is where prompt to leaderboard comes into picture. So folks from LLM Arena have created a leaderboard. For example, if you have a query like, help me write a bedtime story. So this is your prompt, right? So given this prompt, right, it says, this leaderboard says, which is the best LLM for you to give a good response. So here it says Gemini 2.0 Flash is a very good LLM for this kind of a prompt, right? So now suppose you have a prompt where you want to actually do text to SQL. Okay. So what I did was I took the prompt of, from LangChain of how do you generate text to SQL, and let me paste this prompt over here. And now let me say send. Okay. So here it says the best model for these kind of prompts is actually O3 Mini High. So this looks like a reasoning problem, right? So this is an interesting tool called Prompt-to-Leaderboard, which can take any prompt and generate a leaderboard tailored to the prompt in real time. So it tells you for this prompt, which is a very good LLM. So how did they create this particular Prompt-to-Leaderboard? So the authors from LLM Arena have released this paper. So let me go to a summary of this prompt to leaderboard paper basically, right? So prompt to leaderboard is a novel method for evaluating large language models. Instead of relying on average performance metrics like traditional leaderboard, prompt to leaderboard trains a model that predicts how well different LLMs will perform on a given specific prompt. So that is the idea over here. So they have trained a model to do this prediction for you. So this allows for a much more fine-grained understanding of LLM strengths and weakness. It's a generalization of standard Bradley-Terry coefficient modeling for pairwise comparisons. Okay, so how was this created? So they started with a pre-trained LLM, an existing instruction-tuned LLM like Qwen 2.5 or small LM2. They replaced the language model head, which is your output, with a coefficient head. So new output layer is added. This layer is designed to output a vector of coefficients, one for each LLM being evaluated. In the simplest case, this is a linear layer. For more complex scenario, it might require a more sophisticated output layer. So what did they train on? They used a large data set of human preference data from Chatbot Arena. So each data includes the following: a prompt, that is your input text, two LLMs that were compared to this for this prompt, a human preference of these two LLMs saying which model gave the better performance or a tie. Okay, so this was the data on which an small LLM was trained to output coefficients. Okay, so the training objective is this model is trained via gradient descent to minimize the negative likelihood of human preferences. Essentially, it learns to predict which LLM will win given a specific prompt. Okay, the output coefficients represent a prompt specific leaderboard. The higher a model's coefficient for a given prompt, the more likely it is preferred by a human for that prompt. And then they did generalization of this called prompt to regression. Okay, so you could have tie between both models and other things can be taken care of over here. So this is how they developed this prompt to leaderboard model, which can give you this prompt conditional leaderboard. So the idea over here is that given a prompt, it can tell you which is a good LLM for this kind of prompt. So which LLM kind of generates very good outputs for this kind of a prompt. That is the whole idea over here. Okay. So what are the uses of this? As I said, one is like to find out which LLM is better. So you can do optimal prompt routing. Given a prompt, this can predict which LLM will perform best. And this is dynamic prompting. So you can choose, if you have a choice of models, it can send to that particular model. You can design a system around making this P2L as an optimal prompt routing or a router, right? You can do personalized evaluations by aggregating the predictions over a user-specific prompt history. You can create a personalized leaderboard showing which models are best for the user's typical tasks. You can get the strength and weaknesses of different models. Say, for example, for math, which model is good? For creative writing, which model is good? So given a model, and if your use cases spans across 3 or 4 types of prompts, then you can figure out which model is good for this particular task, right? So this could also lead to efficient evaluation. The traditional leaderboard requires a large amount of data. So here you can quickly create with less individual prompts and with much less data. And you can look at which model generalizes well to unseen prompts. Okay, so this is a very interesting work, this prompt to leaderboard. So you can also look at this prompt to leaderboard with your specific prompts to see which models are really good, and then probably you can try and evaluate them and see that, okay, do these models really perform well as predicted over here? Okay, but this is a good start for you if you are starting with, I don't know, for this kind of a prompt, which model is really good for me. Hope this video is useful. I'll share all the links in the description of the video. See you in another video.